Hello. So, in the last class, we talked about splitting of springs into part. Now, in this class, we would be talking about, as you can see the heading, combination of spring. This is our fourth video, and basically, what we are dealing, it would be helpful for you in all the teaching exams where physics is part. So let's talk about combination of spring. So as we know, there are two combination of spring which we have to study. One is parallel combination and other one is series combination. So what is parallel combination of spring? So basically, in parallel combination of spring, that is, if springs are connected in parallel, then remember that magnitude of displacement, if the magnitude of displacement is same and direction of force is same, then it is called parallel combination. For example, you can see in the figure that there are two springs having spring constant K1 and K2 and a block is connected with them. Now, if this block is stretched by a displacement of x, then you can see that in both the springs, restoring force would act in the same direction. That means direction of force is same, whereas both the springs would be displaced by an equal amount. So this is an example of parallel combination of springs. So in parallel combination, you have to always remember that magnitude of displacement is same. What is same? Magnitude of displacement is same and direction of force is same. So as we know that force, restoring force equal to minus kx. So for the entire system, the restoring force F dash should be equal to sum of the restoring force F1 plus F2, and F1 equal to minus K1x and F2 equal to minus K2x. Therefore, F dash, which is equal to minus K dash x, should be equal to minus K1x minus K2x, and from there we get K dash equal to K1 plus K2. How you can solve it? See it out. A body of mass m, and there are two springs of spring constant K1 and K2. Now if it is displaced by a distance of x, that is, if this same spring is stretched this length and this is equal to x, so what would be the restoring force acting on upon one? F1 equal to minus K1x, and on downward one would be F2 equal to minus K2x. So entirely, for the entire system, if restoring force is F dash, that is equal to F1 plus F2, so that is, if the equivalent spring constant, if you take it out to be K dash, so minus K dash into x should be equal to minus K1x minus K2x. From here we get K dash equal to K1 plus K2. So in parallel combination of springs, k dash equal to k1 plus k2. This is of parallel combination. Now what about in series? Suppose there are two springs A and B having a spring constant K1 and K2. They are connected in series, right? So in series combination, most important thing here in parallel, what was most important was, so what was important was that in parallel combination displacement was same, and what was different, force was different. So we took f dash equal to f1 plus f2 and then replaced it with x, and x got cancelled because it was same. Here in series combination you have to remember what is different. Here displacement would be different if these are stretched by some force. Then here in series combination displacement is different, so x dash would be equal to x1 plus x2 and force is same. Restoring force acting on this spring, if it is F equal to minus k1x 1, then here also restoring force would be F equal to minus k2x2. Force would be same, and on entire equivalent system also force is same. Let's suppose F equal to minus k dash x dash. So what is x dash? X dash comes out to be minus F upon k dash. What is x1? From here x1 comes out to be how much? Minus f by k1, and x2 comes out to be from this one minus f upon k2. So from here all these f got cancelled and we get, what do we get? 1 by k dash equal to 1 by k1 plus 1 by k2. This is for series combination. Understood? This is for series and this one is for parallel. So that's what we have done here. In combination of spring, first was parallel. So what is parallel combination of spring? Magnitude of displacement is same and direction of force is same, and we get k dash equal to k1 plus k2. Whereas in series combination magnitude of force is same and we get 1 by k dash equal to 1 by k1 plus 1 by k2. So here we are ending this, but just after this we will follow with another lecture in which we will be talking about some more important things. So let's continue with that.